Hi, my name is Puya. I'm MYK student, and in this video I'm going to introduce and present my personal project's final product. So basically the topic that I've chose is IPS, which is short form of Indoor Positioning System. My Indoor Positioning System is exactly function as GPS that we use in car in daily life. But GPS actually works based on 24 satellites which are placed in orbits. So it can work in any weather condition and 24 hours a day for free. But the problem that GPS has is that you are not able to use GPS inside a building or in an underground bridge or parking. That's why this idea hits me that I can create an indoor positioning system that can locate the position like GPS, but inside the building. So for this idea, I've used a principle called echolocation. This principle actually bats use to locate the subject in front of them and to locate their position and locate the insect. So this idea is exactly works based on their bat's function. So I've placed 4 ultrasonic devices on my car. This part, this part, this part, and this part, which are 4 sides. So when I start this device on, these ultrasonic start to send signals simultaneously, and they send signal rapidly 3 times a second, 3 times a second. So when and every time they send signal, they send a pulse of ultrasonic, they receive the time of echo. And based on a simple mathematical formula, which speed is equal to distance traveled over echo time, when the time can be measured accurately, if time measured accurately, and ultrasonic speed is known, so distance can be known. It's like, because distance traveled is exactly 2 times more than from wall to the car, because like one it's go to toward the wall and the other one it come back, so it's like 2 times the distance of the wall. So when these signals receive the time, these signals transmit or actually collect this information and store it on microcontroller, which is this black part. Microcontroller is the head manager, or it's exactly like the brain of this system. So it's actually collect the information and based on the programming, convert this echo time, convert this time to the distance. So microcontroller can be known as a simple or a small PC which can be programmed. Okay, after that microcontroller change this echo time to distance, it will send this kind of data to my receiver by antenna. If you can see, I have placed 2 antennas, one here, one here. So the ultrasonics, the microcontroller will send this information to my receiver, and this information will be present as y-axis and x-axis on my receiver. So let's see how it functions. So I start the device on. Connect the power. Okay. So as you can see, the numbers on the both LCD are same. So every time these calculate data or collect the data, they send it for my receiver. So let's try it. Okay, so as I mentioned, as the car is moving and rotating around the room, so this information about the distance from each side of the room, x-axis and y-axis, sends simultaneously to the receiver. So if I move the car, we can see that, for example, in this position, the coordination is, for example, 0 and 0 because attached to the wall. As you can see, it's like the ultrasonic are blocked by the wall, so it's 0 and 0. So if I move it to the center of the room, as you can see here, the coordinates are 170 and 285 cm. The first one is x-axis and the second one is y-axis. And number above is the bearing or the degree.
Okay, let's say this device over here shows a few coordinations, but how to make sure that we know where it is located?
Okay, so on my device I have 4 ultrasonic. So actually I can receive 4 distance. But because it was so confusing for everyone to read the signal, that for example, it's like which side is 40 meter or which side is like 20 meter. So I've only chosen 2 of my coordinations, 2 of my distances. And in my programming, I set only the right and, for example, the right and north ultrasonic wards in a specific position. And if you see on my device, I've used the angle or bearing. If you see here, it's 41 degree. So when it's like 30 cm and 218 cm in 41 degree. So if when the angle or the bearing change, the coordination obviously like change as well.
Okay, you're using a remote control car as for your Unifig. What else can it apply to? Can it apply to a phone? Or let's say if a security guard in some museum would like to search for some item which has been lost or something, how does it apply in the future?
Yeah, sure. It's like, actually the main principle is its echolocation. So only the principle that I've used the echo time to measure the distance, I've used it on car, but you can use it on phone. So for example, but your phone should be able to send any signal. For example, in my car, in my case, I use ultrasonic. But in the real life situation, we are not able to use ultrasonic because ultrasonic will be blocked and distracted easily. So for example, in real life situation, we may use radio signal. For example, as my phone sends radio signal to the wall and take the echo time and tell the coordination. It can be applied. Question?
Yeah, I'd just like to find out about the distance of this thing. Is there a limit to the distance? Like suppose say, adding to his question, like you have a museum, right? You know, a museum association.
Yeah, exactly. Okay.
So what's the maximum limit of?
So it's like, my aim was to do it in a small scale, like to present the Indo-Pacific system in a small scale. So the maximum distance that the ultrasonic can cover is like in a room 10 meter and 10 meter. So if we go in a bigger area, the ultrasonic is not able to detect the position. So that's why I'm saying that in the real life situation, we are not able to use this method. I mean, the method and the idea can be applied, but the same signal cannot be applied. So the signal should be changed, like Bluetooth maybe, to radio frequency maybe infrared. Any question? Challenge, come on.
So are you saying that rather using supersonic,
Sorry?
what was the effect again? What was the thing you used?
Effect?
Ultrasonic. Okay, one more time.
Okay.
Let's say now you're using the ultrasonic frequency. Can it be used as in Bluetooth?
I have researched a lot about different types of signals, to which one is the best in my own type. So it is even possible to use Bluetooth, yes, as well, because Bluetooth have an even higher range. It can cover until 50 meter. Ultrasonic is only limited to 10 meter. So it's like other signal in radio, for example, radio frequency as well work even maybe better. But in my case, I couldn't use with radio frequency because radio frequency have a very, very high speed. So it's really hard to detect the time, the echo time of them. And Bluetooth as well.